Okay, luckily my daughter was walking by when she saw that my phone just stopped on me and I wasn't able to lose too much footage. But I think where I had just gotten to was I noticed that this summation here involves I, expressions that have I in it. So this is f of I times something. This has got an I in it, but 3 over n can be treated just like a constant. So we can move that in front of our summation. So we can move the 3 in front, and then I noticed that I left off something here. I was about to do this wrong, so let me just see what I'm supposed to do here. You can move this is the limit as n goes to infinity of 3 over n, and then we can do the summation of I is 1 to n of f of I 3 over n. Now the next thing I'm going to do is rewrite f of I 3 over n. I'm going to plug it into the function. That f of x is defined to be this. So this is what I'm going to put in for x. So this is equal to the limit as n goes to infinity of 3 over n times the sum from I is 1 to n of f of this. So f of this would be something cubed minus 6 times something, and what we plug in is I times 3 over n, I times 3 over n. Just like if you're taking f of 2, you would stick in 2 for x wherever there's an x. We're just substituting in that expression just to remind you what we're doing. Okay, so let's go ahead and start to evaluate this. This is equal to the limit as n goes to infinity of 3 over n. The sum from I is 1 to n. I cubed is I cubed. 3 cubed is 27 over n cubed minus 6 times I times 3 is 18I over n. Okay, nice. Now what we can do is say, hey, 27 over n cubed does not involve an I, so I can do the same thing here. I can move that in front. Also, 18 over n does not involve an I, so I can do the same thing here. Plus, let's apply some of the summation rules that we know. If you are taking, see, I really and truly should have a big bracket here because we're taking the sum of all of this. And see how this is 2 expressions, but they're being subtracted? I'm allowed to split this into 2 separate summations. So let's do that. Over here, we have the limit as n goes to infinity of, I'll put a big bracket here, 3 over n, and I'm going to do this. I'm going to move the 27 over n cubed on the outside. I'm allowed to do that because no i's in it, times the summation of I is 1 n I cubed. Okay, minus, I'm splitting this into 2 summations, so this 3 over n gets distributed over here, because at this point this is still in one big parenthesis, one big bracket. And all at the same time, I'm going to move the 18 over n in front like a constant because there's no i's in it. Times the sum from I is 1 to n of I. Now, look here. We have a formula we can use for I cubed. We also have a formula that we can use for I. So I'm about to do that. This is the limit as n goes to infinity of 3 times 27 is 81. N times n cubed is n to the 4th. And then this summation, I is 1 to n of I cubed, is by formula, that is equal to n times n plus 1 divided by 2, the whole thing squared. That's just a formula. All right? I still want this bracket because the limit's going to apply to both of these things. Okay, minus, let's see, 18 times 3 is 54. 54. N times n is n squared. And then by formula, see, there's a formula for the summation of I, and it is equal to n times n plus 1 over 2. All right. we're making good progress. Now what I'm going to do is I'm going to square this. So the limit as n goes to infinity of 18 over n to the fourth of n squared, n plus 1 squared would be n squared plus 2n plus 1, 2 squared is 4, okay, minus 54 over n squared times n squared plus n over 2. Okay, this is what we have. I'm just simplifying my limit now. Let me make sure I'm still on the screen. Okay, I'm going to move this up a little bit. All right, here we go. So let's see what we got here. This is the limit as n goes to infinity. I'm going to move this 18 over 4 into the fourth is what I have. 4 into the fourth. 18 times n squared is n to the fourth. Plus 18 times 2 is, what is that? 36 n plus 18. Let me make sure I'm not making a mistake here. Ding, 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 ding. Yeah, I am. I transposed that. That's not 18, is it? That's 81. I thought something was funny. Sorry. There, that's better. Alright. Minus 54 over 2 n squared. And what's happening up here? We have n squared plus n. Alright. Now, if you remember infinite limits, when something's going to infinity, the rule is to divide by the highest power of n if you need to, but it's already happening. So I'm going to split this into little bitty fractions so you can see what's happening. This is still the limit as n goes to infinity of 81 over 4 n squared into the fourth over n to the fourth, plus I'm gonna bracket out this 81 over 4. N to the fourth over n to the fourth, plus 36 n over n to the fourth, plus 18 over n to the fourth. Okay, minus 54 over 2 times n squared over n squared plus n over n squared. All right, what happens when a limit's going to infinity? The limit is applying to everything is, if the power in the denominator is bigger than the power in the numerator, this is going to 0. This is going to 0. This is going to 0. N squared over n squared is a big 1. N to the fourth over n to the fourth is a big 1. So what we end up with is 81 over 4 plus 0 minus 54 over 2, which is a 27. And when you add those numbers together, you get negative 6.75. Okay, what this is a very detailed way of determining the integral without using the integral rules. Let's just check it real quick. What we know how to integrate. Let's integrate x cubed minus 6x dx. This would be x to the fourth over 4 minus 6x squared over 2 from 0 to 3. This would be 1/4 3 to the fourth minus 3 squared, let's see, 3 squared. When I plug in the 3 minus, this is going to be a big 0. So that's going to be 3 to the fourth is 81 over 4 minus 3 times 3 times 3 is 27. And we get the same exact thing when we integrate. So what Professor Flores is showing you is the roots of integration. They are infinite sums, and so he was just showing you how you can use some of those formulas to evaluate it that way as well.